Okay, so we we're just waiting to see who's joined in. Yeah, the participants are joining in, so let's give them a minute or two here, folks, so I can see the participant list increasing in numbers.
Usually takes about 5 when we're doing it with overseas webinars, Vijay. So
it takes what?
Takes about 4 to 5 minutes to get.
I see. Okay, so please bear with us. And are you able to see my screen that I'm sharing?
Yeah.
That's okay.
Vijay, do you want to start
so
welcoming people as they join?
Yeah,
I mean,
yes,
we still
yes.
wait a few minutes. But
Yes. So good evening, everybody in India, and good morning to those of us who have joined from the United States. And if there are any participants who have joined from anywhere else on the planet, our sincere greetings to all of you. Please hold on for about a minute or so. We'll give participants time to join in. We do have about 100 of them, 94 of them who have registered for this, besides the panelists, of course, the distinguished panelists and our moderator here. Please give us a minute for allowing others to join in. And hope everybody is doing well. It's awesome and energizing to know that this is a Sunday for most, if not all of us, unless somebody has joined in from probably Australia or whatever. But what's energizing about it is that you'll have chosen to spend an evening on a Sunday to discuss a career journey that you can possibly embark upon. And that I see personally as a very big step, or a very big next step in your aspirations. And I thank all of those who have already joined in, and everybody else that's going to join in later on as well, for allowing us this opportunity to bring to you an engagement with Carnegie Mellon University, the world's #1 school in computer science, and with distinguished Professor Dr. Bhiksha, who is able to spend time with us this morning on this webinar, and our Director of Executive Education, Mr. Ram Konduru, as Director of Executive Education at the School of Computer Science in Carnegie Mellon, also joining us from the United States. And then we do have others as well, Dr. Praveen Garimella, and we have Ms. Mathangi Sri. They will all be introduced shortly. So we are looking forward to a very interactive session, and we want to make sure that you obtain the information you require to aid your progress in your interest in AI and ML and deep learning. So that said, just give us another couple of minutes here. I'm just trying to track down to see. We've got about a third of the registered participants in. It's 9:34, and we will jumpstart at 9:35. Okay, so hold on. Thank you very much for your patience, and hope everybody is doing well in the face of the pandemic. Turns out that we are a little about over a year since it was first announced. most of the world. And hopefully all of you are safe wherever you are, and looking forward to a bright 21. Okay, so that said, let's get started. We are almost there. Let's see, we'll do one more check. Okay, so let me make some leading comments here. My name is Vijay Sai, and I am the Managing Director and Chief Advisor of Turnkey Learning, which is bringing education in collaboration with Carnegie Mellon to India, make it accessible and feed the aspirations of young working professionals and even those who might have freshly graduated from college. Folks who have an engineering background, a computer science background, even otherwise any other background, but have a background in programming and have a desire to participate in the future of work, which is going to be digitally transformed in ways that AI and ML and deep learning are going to be at the core of what we see working professionals and businesses adopt for the future that we are all facing. So in doing so, I have invited a distinguished panel, which is having some very distinguished participants here. And it's a very diverse panel in some sense. And we look forward to participating in your journey and your aspirations. And as I said earlier, I thank you all, each one of you, for allowing us the opportunity to be part of that. And I do welcome the panel members as well as every member in the audience here today for making time to participate in the session. This session is going to be recorded and it will be available on Turnkey Learning's YouTube channel, which you will receive a link of following this webinar. You should receive it in a day in your emails. That said, I would like to invite Mr. Ram Konduru. He's the Director of Executive Education at the School of Computer Science. Ram has spent a significant amount of time at Carnegie Mellon, and he has got a handle on the business at Carnegie Mellon like none other, in my personal opinion. I have had an association with Ram for several years. Ram is also a graduate from Carnegie Mellon. He has earned an MBA degree at the Tepper School of Business, and he has been heading up the School of Computer Science Executive Education program, and he handles literally 7 major departments at the School of Computer Science, and he handles the interactions with a number of faculty, and he's committed and passionate about reaching Carnegie Mellon content to the world at large. And Ram, you want to take it away, please? You're muted, Ram.
Thank you, Vijay. Good evening, everyone. A brief intro about myself. Like Vijay said, I actually have a technical background. I was an engineer by training, but I decided to move into the business side. I have an MBA from Carnegie Mellon. I've worked in industry in the US and Europe for about 15 years before coming back to Carnegie Mellon, so that I have the opportunity to work with people like Professor Bhiksha, colleagues who make me stretch my mind every single day. So it's been a very exciting journey. One of the focuses of the last year and a half or so is to increase access to our world-class faculty and their excellent content all over the world. This partnership with Turnkey is one such program where we're working with Vijay to offer this program in India, because honestly, we marketing and execution is not our forte. Educational content is. We'll be starting in this fall. We're going to be offering many more courses, both online and offline as well. The great thing about this is, how do I put this? You by participating in our executive programs, you'll have access to unique upskilling opportunities without having to take 2 years off to come to Carnegie Mellon to get a graduate degree and also specialize in that very narrow area that you might be interested in if you don't have the time or not able to take the time off to get get a master's degree for that matter. So I'm really excited about this program, and there are many more that Vijay has in the plans. And with this, I'd like to turn it over to Sirisha. And I'm happy to answer any questions. Feel free to enter them in the Q&A chat bot while we're talking.
Thank you very much, Ram. Sirisha?
Thank you, Ram and Vijay. Good evening to everyone. I take this opportunity to introduce the speakers for today's webinar, Introduction to Deep Learning, the Program and the Prospects. Our first speaker is Dr. Bhiksha Raj, Professor at Language Technology Institute, School of Computer Science at Carnegie Mellon University. Dr. Bhiksha Raj has devoted his career to developing speech and audio processing technology. He has had several groundbreaking contributions in the area of robust speech recognition, audio analysis, and signal enhancement. He has also pioneered the area of privacy-preserving speech processing. He will be providing us information on the Introduction to Deep Learning program being offered by Turnkey Learning. Our second speaker is Ms. Mathangi Sri, an accomplished industry AI leader and data science influencer. She is the head of data at Gojek and is recognized as the top 10 data scientist in India. She will share her experiences on the value proposition and adoption of AI, ML, and DL in the industry. She will also provide her insights on the roles and opportunities that are present for such skills. This webinar will be moderated by Mr. Praveen Garimella, who is also the Chief Academic Officer at Turnkey Learning. As the current Associate Dean of the Consortium of Institutions of Higher Learning, CIHL, Praveen has designed and executed many interactive learning methods to improve learner efficacy and learner competency. Mr. Praveen is an adjunct research fellow at Carnegie Mellon University, and his areas of research pertain to the use of AI for education. I now request Mr. Praveen to proceed with the session. Thank you, everyone.
Thank you, Sirisha, and welcome everyone. So I'm going to try and do the moderation for the introduction to the deep learning course. So feel free to post all your questions while we have the panelists first giving their introductory remarks, and then I will try to pick the questions, maybe all of them, but if there are too many, try to pick the most important ones and then hand them over to the panelists. So, so I would like to invite Professor Bhiksha Raj to give his opening comments about the Introduction to Deep Learning course. Professor Bhiksha.
So, yeah. Thanks, Praveen. Hello all. I hope you can hear me. If you cannot hear me, just let me know. And again, you may post your questions to me or both while I'm talking now and later during this webinar on the chat. Now, first, I've already been introduced, so I don't need to introduce myself. Let me begin by talking about the course itself. The Intro to Deep Learning course that we will be doing in this exec program is a modified version of the Intro to Deep Learning course that we do at CMU. So much of what you will be seeing in the course is what my students see at CMU. The objective of the course over there is not so much to develop research-ready deep learning professionals, deep learning scientists. The objective is to produce industry-ready deep learning professionals. So most of the students who come into my course at CMU come in with basic knowledge. They know how to program. They know something about the linear algebra. They know something about probability, and they've heard lots about this fancy new technology called deep learning, which is changing the world, and they want to learn more about it. But they're in a hurry. These are CMU students. They want to know. They want to spend exactly one semester, and at the end of the semester, they want to be able to go off and participate in the industry and contribute and get good jobs based on their deep learning knowledge and more. So this is a pretty tall order, and what we've done over the past several years is to construct a course program that pretty much does exactly just that. So over the course of a semester, students who come in knowing very little end up at the end of the day, they are generally astonished and often shocked at exactly how far they have progressed and how industry ready they've become. So again, they're not going to, the objective over here is to prep them to be able to take on any task. The objective here is not to make them widely knowledgeable on every research area on the planet. That is not something that you're going to be doing in one semester. The title of the course is Introduction to Deep Learning. It's not really an introductory course again. It's introductory in the sense that you will become fairly comfortable and able to do all kinds of, able to actually participate to build systems and work on industry level projects, but not be at the cutting edge of the science doing your own research, because that actually will need a lot more advanced knowledge. Anyway, so for this exec program, that is our objective. We are going to try to summarize exactly what we do over the course of a semester into 10 weeks. The distinction between what we do in CMU and what we do over here over the course of 10 weeks is that we cut out a lot of the topics that graduate students are interested in. We also take advantage of the fact that graduate students who are in CMU over the course of a semester are not taking just my course, they're taking 4 or 5 courses alongside, and so things have to be stretched out. Whereas we assume that people coming into an exec ed program are fairly directed, and so the entire syllabus can be compacted. At the end, what you will learn during the course is much of the basic theory, the ideas, the whats, the hows, and the whys of how these concepts build on. You will also learn how to program basic deep learning programs, begin to build your own toolkit, but then you will also learn to apply existing frameworks on large-scale problems. So you're getting the entire end-to-end experience. You understand enough of the theory to be able to extend what you learn during the course of the program. You understand enough and you have sufficient hands-on experience to begin building some of these tools yourself, because that's something the industry needs. But then you also learn how to really throw what you learned at large-scale problems. Now, the problems that we will give you are sort of tuned so that you can actually solve them over the duration of this program, but still sufficiently large that what you learn makes you directly useful in an industry setting. You will be competing, for instance, with your colleagues on some fairly complex, close to state-of-art tasks, challenges on Kaggle. And you must achieve certain benchmarks. And by the mere fact that you've achieved the benchmarks we've set out for you, we know exactly how good you are. And if you go through the whole course and achieve all of the benchmarks that we set out for you, we expect that by the end of the course, you will be prepared for most industry jobs, which don't require deep, in-depth research level knowledge of deep learning, but expect you to build stuff, just hit the ground running, because you know how to put things together and handle different kinds of tasks, different kinds of problems, whether it be dealing with time series, whether it be dealing with images, whether it be dealing with prediction, classification, or something far simpler. So that's a very high level overview of the course. There's a lot more to it, of course, than what I've just given you, but since I'm using up my time pretty fast, I'll stop right here and I will I'll take any questions that you may have about more details during the Q&A phase. Praveen?
Thank you, Dr. Bhiksha. So I would now like to invite Mathangi Sri to give her opening comments. She has a lot of experience from the industry, so she's going to talk about relevance of deep learning and from the industry perspective. So over to you.
Sure. Thanks, Praveen. Happy to meet all of you on a Sunday evening. Just to take a little bit of perspective, right, and provide applications of AI machine learning in the industry. So we'll start a little on the history side, right? So what used to happen in the industry at least 10, 12 years back is a lot of predictive problems being solved by doing a lot of causal analysis, statistical analysis, or basic regression kind of work. So I personally have built credit risk models, which approve or decline your liability products for a bank, etc., at large scale, right? But once with the advent of data science, with the advent of large scale data, with the advent of infrastructure to combine this data and algorithm, machine learning became fairly widespread in the industry. And that's when, for a lot of use cases, some of the digitally first organizations are at the forefront of using machine learning in their day-to-day work. Be it your on-demand services like, some of the food delivery companies, some of the cab delivery companies, etc., or be it your e-commerce, machine learning kind of is at the forefront, delivering very different use cases. So for example, search and recommendations is one area. So I could classify the applications into three major buckets, right? One is on things like text understanding, natural language processing, things like that. The other bucket is another type of data on image processing and everything. The third bucket is also very interesting. It's on personalization, right? So that's where your search optimizations or recommendation optimizations, etc., come. There's another fourth area which is on voice processing itself. But fundamentally, these are the three dominant use cases in the industry for especially deep learning, or some amount of machine learning as well. And again, traditional companies also use some of these techniques, be it banks or be it retail stores, physical retail stores, I mean, use a bunch of these solutions for their assessing the credit or fraud of the customer, understanding the voice of the customer, or things like merchandise and how to arrange your products, what to sell with what, etc. These are some of the tip of the iceberg kind of use cases. In the last 4 or 5 years, at least, the companies that collect huge amount of data have been harnessing the power of deep learning and machine learning methods. They have provided $1 million impact, have been the competitive advantage of a lot of companies as they compete with as they compete with similar players on a day-to-day basis, and given customer experiences itself has become very intuitive, right? So the customer experiences are not what they used to be, let's say 10 years back, right? Today, we are in the world of intuitive customer experience, where you do not want the customer to do a lot of work, right? Including search, for example. So, and if you want to, for example, you open a content app like Netflix, you want to show, the top things that the customer has to watch. So they're not even thinking actively on, even in entertainment, what to watch, right? So in order to move the industry to absolute personalization, where you are offering price, you're offering product, you're offering the targeting, etc., for the customer, there is enough and more amount of deep learning power that is getting harnessed across various industries, and more so the digitally first organizations. So that's on the application a bit of it. I'll also address a little bit on the career aspect of how does the career work on the data science space. There are, so to say, few major areas, but let us say, so you could broadly classify them into engineering, and data science. For example, and in engineering, you could have people who make the data pipelines, people who do machine learning engineering, which is kind of making sure some of the algorithms run at scale. On the data science side, you have people who analyze data, give point solutions, give actionable recommendations kind of profiles. You also have people who are core data scientists or ML scientists. These are people who build, work with data, understand business requirements, customize the solution, see if what is available in the market, what kind of algorithms can be applied for a specific problem, work with the different teams to make the solutions go live and measure the impact over a baseline control group or something like that. And then kind of roll this across at scale, right? Broadly, those are the roles. There are other roles, of course, on data science itself, getting interface with other entities in the organizations, like your data science product manager, project managers or program managers who are very specific to data science. So those broadly would be the roles as well in the industry. Praveen, over to you, sir.
Okay, thank you. So we have started getting a few questions, so I'm going to read them out here and then request the panelists to answer. So the first one here is, does the course include real-time case scenarios, real-world case scenarios, industry-specific? So Dr. Bhiksha?
So in terms of the assignments, we try to keep it generic. So you're going to work on real world data sets. They're going to be reasonably large. You're going to work on real world problems, but the kind of problems that you will work on are going to be typical as part of your assignments. So we've chosen 4 different tasks. Standard classification task, which requires a specific kind of model architecture, but that model architecture can be translated to any other task in the same family. So we're looking at a standard image analysis task. In the image analysis task, we're looking specifically at face recognition and face verification. Again, you're going to be building systems which are trained on large amounts of data, and you have some fairly high benchmarks to achieve. And the models that you will use in these problems, again, are going to be sufficiently complex and detailed that what you learn from here can be applied to other similar problems. For time series analysis, we're looking at sequence-to-sequence problems and speech recognition, because they're 2 different classes of problems over here. Again, you'll be working on a close to state-of-art data set in both cases, where the data set is not extraordinarily large. It's of the right size for you to actually begin exercising all of the tools that you will learn. And once again, these tools can directly be the tools that you learn can be directly translated to other real-world problems. We haven't chosen specific industry-related problems because once I get too specific to one particular kind of industry-related problem, it sort of excludes other problems. So that's it. During the course and even after, if you're interested in applying anything that you learn, or if you would like to know how to address specific problems that you have, then you're always welcome to come back, and I'm always going to be available and ready to answer you and answer your questions on how you can translate what you've learned during the course to your problem.
Thank you, Bhiksha. Praveen, I have a slightly different take on the question. So let's say, I'm working to the question that was asked. Manaswi asked the question. If I have my own data set, I'm able to do work, use my data sets, from my job or industry or whatever in the assignments that for the course.
So could you? I missed that.
My question was, so Bhiksha, if the participant have their own data set, is there anything prohibiting them from using their own data sets in the assignments that are given?
So there is, in the sense that we have benchmarks. So for me to know that you have achieved a certain degree of proficiency, you need to be able to achieve the benchmarks that we have set on our data sets. That is the reason we are not allowing everybody to go off and work on their own data sets. We have no way of evaluating how far you've got. So the reason for standardized benchmarks is for us to be able to evaluate your proficiency. That said, if you want to do something else on the side, apply what you've learned on your own data set. We will support you on that.
Thanks, Bhiksha.
Thank you. So we have another question coming in. Says that I'm in my first semester currently. So is it a good idea for me to take up the course at this point in time?
In CME, almost all the students who take it are in their first semester. And the reason for this is they're looking for internships, they're looking for jobs, and you want to hit the ground running. They're also looking to join other projects, people who will sponsor them, and you need to be sufficiently skilled that you can take up these tasks and deliver. So it turns out that learning these skills early can be a key and critical difference in both your academic and your industry career.
Right. So one follow-on question I can think of is maybe the CMU students in the first semester coming up with some prerequisites when they start doing the deep learning course. What are those prerequisites for this course, and how should I prepare myself for that?
So the course itself has a very broad clientele within CMU. And the reason for its popularity is really our outreach to pretty much anybody who wants to learn. The prerequisites are, you need to know your programming. This is not a programming course. So you need to have a certain degree of proficiency in Python programming because that is the tool of choice these days. You also need to have, you need to know what a matrix is. You need to know what a vector is. These are basic linear algebraic concepts, which is, which nearly everybody is familiar with from if you've got any kind of a science degree. You're familiar with this from school, you're familiar with this from college, so this should not be an issue. We also expect you to have a certain degree of familiarity with the concept of probabilities and related concepts, because anytime you are performing any kind of inference, any kind of AI task, what you're really computing are probable answers. And so for you to be able to deal with probable answers, you need to know the meaning of a probability. So our requirements are, you need to be able to program, you need to know some basic linear algebra, you need to be familiar with the notions of probability and related concepts. But this is a fairly low bar. We have students who come into the business school, people who come into the arts programs, even the music school, all of them take my course.
So Praveen, to add to what Bhiksha just said, we get asked this question all the time in all of our programs. And for the introductory courses, like Bhiksha was saying, programming is a requirement, not expert programming, but you need to be able to program because you learn some along the way on your own. But to quantify the math requirement, and Bhiksha, correct me if I'm wrong, we say, you need to have high school level understanding in linear algebra, calculus, and statistics.
That's correct.
So,
or your first year engineering. Yes.
Right.
Yeah.
So I have this question in my mind. So when the first time I heard AI, right, or anyone hears AI, they have this image in their mind where they actually see a robot or something which is very sci-fi. Right? And then sure enough, I go do a Google search on deep learning, now I look at an image where I see a very complicated structure. It's probably more scary than a robot. So, and if I go out talk to anyone outside on what deep learning is, everyone has their answer for what deep learning is. So would you like to throw some light on this in terms of how I should think about deep learning, AI, ML, because there's so many words which are so new in this space and everyone has a definition for it.
So it's not you're speaking of three different concepts over here. One is AI, the other is machine learning, and the third is deep learning. And they are sort of, AI is the broadest concept, machine learning is the next level concept, and deep learning is maybe the innermost level concept. So artificial intelligence is, here's a slide that I just sort of cooked up exactly this question. Artificial intelligence, an artificial intelligence system is any system that can perform a task that we humans would judge as intelligent. Now, how it does it is not being questioned over here. So this could be a system that plays chess. This could be a system that moves objects on a conveyor belt, right? It's doing and based on some kind of reasoning. So that's an artificial intelligence system. Now, this is the broadest level. An artificially intelligent system doesn't have to be, it can be an expert system where you just sit down, write a bunch of rules, and code it in. Machine learning is not artificial intelligence. Machine learning is the engine, one of the engines that can produce artificial intelligence. And this is about learning from experience. So machine learning is about learning to perform intelligent tasks by observing data. So machine learning produces AI, but not all AI requires machine learning. So I have a nice example on the next slide. If we can go to the next slide, can we advance the slide? Yeah. So there's this very nice story called The Great Automatic Grammatizator by Roald Dahl. Most of you are familiar with Roald Dahl from Charlie and the Chocolate Factory and related stories. He wrote children's stories. He also wrote adult stories, and this is one of his stories. This is about a mechanically minded man who reasons that the rules of grammar are fixed by certain almost mathematical principles. So by exploiting this idea, he creates a mammoth machine that can write a prize-winning novel in roughly 15 minutes, where he just punches in a bunch of themes, hits a button, and it publishes the novel, and then he puts authors out of business. So if you go to the next slide, here is the question. Is the machine by itself AI? Yes, it's artificial intelligence. You have this machine, someone fed in a whole bunch of rules, and now when you give it an input, it works on all of the rules, and it produces an output. That is a fixed instantiator. It has not observed any data. This is something that was built, that was kind of monolithically built. And so it's AI, but it's not machine learning. But now suppose the same machine were to print books, these books go into the bookstore, and some make it to the bestseller list and some don't. It takes feedback from this and updates its rules to say, what is a better thing to do and what is a worse thing to do. Now it's learning from data. Now this becomes a machine learning system. So a machine learning system is a system that learns from data to power artificial intelligence, but artificial intelligence itself is the larger concept. Now, what is deep learning over here? Deep learning is one of the ways in which you can learn from data to make appropriate inferences. So deep learning is one of the many machine learning techniques, and arguably currently the most successful machine learning technique in the world today. So deep learning is an instance of machine learning, and it can be used to generate AI. So that's the hierarchy over here. They're all very different.
Okay. So we have a question on Everyone is talking about deep learning, but how to find the right jobs in deep learning industry? What skills are required other than deep learning from a student with mechanical background? So probably this question, Dr. Bhiksha, you could probably take that, and maybe also Mathangi.
So right now, from my perspective, I can only talk about the deep learning side. Mathangi might be the better person to answer the bigger picture. But we find that in CMU, at least in my experience, we have students from the entire range of fields, the entire range of disciplines who are taking deep learning. This includes civil engineers, this includes mechanical engineers, this includes biomedical engineers, the whole lot, electrical engineers. Because it turns out that in today's world, every single problem where you have any kind of design choice, any kind of inference, any kind of prediction to be made, it works best when you employ some variant of a deep learning model. And so mechanical engineers, for instance, use deep learning models to make predictions about not just design, loads, stresses, you name it. There are many different applications where mechanical engineers can use deep learning. My civil engineering students have actually used models, deep learning models, to design structures. The biomedical engineers use these deep learning models from everything to predicting protein structure to designing medicines. So in every one of these areas, if you're working in something as simple as the hotel industry, things like predicting when you're going to get, where to allocate your resources, when to expect clients to come in, how to adjust your expenses, all of these, the entire logistics are best dealt with deep learning. So regardless of the field, these days deep learning, every astronomy uses deep learning, you name it. So regardless of the field, these days deep learning basically gets used everywhere. Right from designing structures to computer science models to medicine to biomed, you name it. But Mathangi might have a better answer.
Yeah, thanks, Dr. Bhiksha. So I'll take from the point you left, right? So a little bit focus on the skills to get into the industry. One is certainly, on the hard skills, you don't need to have, understanding of machine learning, working knowledge of machine learning. How you apply deep learning to certain problems, your application, how you apply it to real world data sets. This is very important. And also it is important to be able to come up with a mathematical formulation for a business problem, right? So that kind of sets apart a person who has experience in the space to not so much experience in the space, or someone who can understand the business, contextualize it, and relate it to a mathematical formulation or a deep learning architecture, right? So that is the big difference that I see between people, as I work with different people. That's one thing that differentiates, different folks. Certainly the hard skills are important, but also what is important is converting a business problem to a mathematical formulation and working through the whole, scaling up the machine learning processes. As much as we want to have some of the deployment systems for the machine learning models to be state of the art, but there are gaps and deltas to be met by a data scientist. So today, a data scientist is not only required to build the basic data science model, deep learning architecture, etc., but also to take it to the last leg of putting it into production systems and thereby kind of scaling those. So that also is required. And interestingly, on the background that that this person has asked, people do come from all different backgrounds, to practice machine learning, to be a data scientist in the industry. So background is not as much as a problem, as much as your skills and what you can prove and how much value you can add with your knowledge and the way that you apply some of these techniques to a real world problem.
Thank you, Mathangi and Dr. Bhiksha. So there are no questions on the chat, but I was thinking about, okay, now this field is so exciting and we have also seen some of the prerequisites and the skills that we expect to use. How is the course organized and what kind of support do I get as a student to be successful in this course?
So with the course itself, we have spent a considerable amount of time trying to streamline the whole process. The course itself is organized along 4 lines. First, we have lectures delivered by me, which are going to be mostly at the concept level. So the lectures might have things like pseudocode, but the main point of the lectures is to teach you what you're doing and why. Then we also have different kinds that we have assignments, homework assignments, which is where you learn your hands-on. So in the homework assignments, again, you have 2 different types. One set actually is where you actually begin building your own little deep learning system from scratch, where you build these models of all kinds. So there are models with different kinds of architectures, straight up NLPs, convolutional neural networks, recurrent networks, learning how to perform forward inference, learning how to actually perform back propagation and learn parameters and such like. And then the third aspect of the course is going to be competing with your colleagues on real large-scale tasks. Large scale over here is in a relative sense, because these are large scale to the extent that we expect you to be able to do it within the 10-week period that we have for the course. And you'll have 4 of these assignments. These are on standard data sets, which are quite big, and where we have a reasonable idea of the state of the art. And you will have to achieve certain benchmarks, which are fairly close to the state of the art on these tasks, and I expect all of the students will do it. Now, to support these students, we have a whole bunch of teaching assistants who will be conducting several office hours every week, and essentially trying to handhold the students through all of the work. The idea here being we are heavily invested in making sure that at the end of the course, every student has basically hit all of the benchmarks that we have set out for them. And pretty much all the help that you will require is going to be made available. I will also be holding office hours once a week, but more importantly, any of the students in the course can reach out to me over email at any time. I'm going to be accessible to them through the course, through the period of the course, and thereafter too, if they ever want. So there's a in terms of infrastructure, again, this is fairly infrastructure intensive. They're going to require something like Google, Amazon Web Services or Google Colab. So as a side benefit, students will actually learn to work on these cloud platforms. And that itself is a skill worth learning, in my opinion, because being able to work on cloud platforms is a big deal these days. Everybody expects you to be able to work on cloud platforms. So this is something that they will learn various aspects of. The evaluation is going to the evaluations that they have are going to have auto-graded components for the standard formalized assignments. Kaggle for the competitive ones. Kaggle is where they will learn most, and if they have any other kind of spirit I expect the students to have, they will end up trying to beat each other, and that is the process where you actually learn more, because there's nothing like the sense of competition to actually make you excel. Now, in terms of, finally, we also have CampusWire, over which you can post questions, so you don't have to go to talk to teaching assistants during office hours. You can post questions on CampusWire, and you will get responses from the TAs and myself. So this is going to bear, and this is also sort of aimed at helping you through the coursework. And there's one final component that I sort of missed out, which is we'll have weekly quizzes, fairly simple ones, which are going to test your whether you've actually gone through the material for the week and how much of it you have understood. Now, we expect you to achieve certain benchmarks on all of these. And it's in our best interest and your best interest to make sure that you actually achieve these benchmarks. So there will be a considerable amount of effort that goes into helping you on every one of these tests. The course itself ends in 10 weeks. We will continue to give you 2 more weeks of slack time for you to finish any residual tasks, just so that when we finally say you're done, you have achieved all the at least the minimal benchmarks we've set out for you, if not the best ones. So at that point, if you achieve all of these, we will think that, and I'm sure you will agree, that you're actually now ready to go and work on, take on any reasonably complex deep learning task on your own.
Thank you, Dr. Bhiksha. So there's a question on how much time should I be investing per week on, because they're assignments. So, and if it is possible for the participants to do if they're already working.
So again, this is something, this is the first time you're doing the course. So, you know, there's a certain degree of uncertainty about how much time you will have to invest in it. Now, speaking from the perspective of the instructor, I'm assuming that somebody who spends, you know, whatever money, whatever investment that you're making in the course is willing to put in 8 to 10 hours of work on the course per week. But then whether that will be sufficient or not depends on the student, depends on how quickly they can catch up with concepts. And if it turns out they can't keep up with us, then, you know, we may have to we'll have to take advantage of the slack period, you know, the extra time that we have at the end of the course. We will have deadlines, but the deadlines are an administrative necessity, because without it we will never end, right? But these are not meant to dismay and discourage students. These are meant to give them a metronome to work with. But if they fail to keep the beat, we will still assist them in trying to get past the humps.
So Ram, see your hand raised.
Yeah, so this is a question we get asked a lot. So, and I run multiple programs all over the world. So this is definitely geared towards working professionals. So I want to say 100% of the people that will participate in our executive programs are more or less working professionals. When we do online stuff, there might be some students, but just picking up on what Professor Bhiksha said, at a very minimum, you're looking at 3 hours of lectures from Professor Bhiksha, and then you have an hour and a half of office hours. There's 4.5 hours right there. So you are, in order to be able to keep pace with the content and get the most value out of this course, let's say you're a genius, then at a minimum, you're talking like 8 hours, as Professor Bhiksha was saying. But it is possible that, you know, if you're learning programming and if you're learning additional concepts, you might need to spend more than 10 hours a week. So I've had programs where some of the students, not all of them, have spent up to 15 hours a week to keep pace with the program, but they come out ahead at the end of the program. There'll be significant learning. So in that sense, it's varied. I wanted to add the outlier also there, because this is a significant course. I mean, even though it's an introductory course, it is a significant course. And to get the most out of it, you need to commit to the time that is required.
Yeah, and again, the amount of time that it will take depends on how much preparation you come in with.
Right. But it is 100% geared towards working professionals, for sure.
Right. So there's a question from the job placements point of view. When I finish this course, what can I expect from the placements point of view?
So
yeah.
Would you like me to take that? Sorry,
yeah,
go ahead.
Yeah.
Okay. So the way Turnkey is now designed to help with placements is that we have an engagement with an organization, a placement organization called Million Minds, which has been empaneled with a number of companies in India, which include the likes of Cognizant and IBM and Tech Mahindra, and so on and so forth. The idea here is that for those registered students who are looking to be placed, we will receive their profiles, updated profiles, to include the course that they've registered for. And then we will start sending out those profiles to Million Minds in order for them to begin to start marketing those profiles. So that is how we are structured to help with placements. And you can check out Million Minds online. And it's also in our brochures. And you will also be able to speak to our frontline sales team, and they will give you information. It's Million Minds Infotech, and you can Google them out. And we will send you the link for that. Sirisha, if you don't mind, please take a note of that. We will add the link to the emails that we will be sending out tomorrow to the audience. Hope that helps.
Thank you, Vijay. So there's one other question. This is an interesting one. Apart from the content, why should one come to Turnkey for the courses? What is the key differentiator?
So, okay, Vijay, saying?
Dr. Bhiksha, you can take it. And
okay, so
it's a two-part question, Praveen. You read only the first part.
Right. So in the market, there are several courses with much less price, I guess. What is the benefit of coming to Turnkey?
Okay, so I can tell you about what you're going to do in this course. You can go to many of the other courses. The real difference is going to be the hands-on work. I can always, beat my own drum and say I'm a better teacher than anybody else, but that will be, that's going to be open to, opinion. What is not open to opinion is that you will be participating willy-nilly on some fairly complex tasks. The assignments that we set up and the manner in which we've set things up. This is not something that you're going to get in any other course. So in order for us to be able to have the kind of evaluations and tests and the work assignments that we've given you, we have to invest a lot of time into it ourselves in the form of setting up these assignments, giving you the necessary infrastructure and teaching assistants and such like. It's highly time intensive even for us. That's the kind of time intensity you don't really get in other courses. And I'm not aware of to date of any course that's actually going to put you through the kind of rigmarole that you're going to go through when you go through our course. So when I say that at the end of the course, you will be skilled, what I mean is that somewhere along the way, you will shed tears. Somewhere along the way, you will be frustrated. Somewhere along the way, because, it's not just, you're not, if you really want that certificate, you can't just be a dilettante who's just dabbled in a few things on 40 different topics and have some vague idea of what is being said. You are going to really be fairly deeply involved and deeply engaged in what you do. These tasks will be complex. The implementations will be complex. You're going to be working on real platforms. This is really an industry level challenge. We're giving you 1, 2, 3, 4 industry grade assignments that you will complete. And these are supported, backed up by the corresponding course material, right? So that is going to be the key difference, that it's geared towards very intensive in-depth instruction.
Thank you, Dr. Bhiksha. Vijay, would you like to add anything? There's a question also about the CMU certification.
About the fees, you mean?
Apart from the contest and methodology of the course, will I get CMU certification?
Yes, so yes, there's a certificate of completion that will be issued by Carnegie Mellon University on Carnegie Mellon stock certificates. and it will be signed by Carnegie Mellon. Turnkey has no role in the issue of that certificate. It is entirely and exclusively the work of Carnegie Mellon. So for those who succeed in this program, who are willing to have a positive attitude and who are willing to have an aspiration to succeed, you are going to be given the infrastructure, the content, and the support. And that is the responsibility that Turnkey brings to the table. And thanks to the engagement with Carnegie Mellon, we are going to make that happen. And that is going to launch you into the career that you're trying to launch for yourselves. So I hope that answers the question.
Thank you. So it's 8 p.m. in India. So I think we have come to the closure of the session. Thank you so much for having all these questions. And thank you, Dr. Bhiksha and Mathangi and Ram for responding to them. Thank you so much. So I'll hand it over to Vijay with that.
Yeah, once again, this was a very energizing session, as I had mentioned. There were a lot of very good questions. There was very good discussion. There was a lot of context about what prospective learners might end up facing. Thank you, Ram, for your words, as well as for Dr. Bhiksha Raj, as well as Mathangi. This is really amazing. I think these are very important questions for aspirants out there. And Praveen, thank you so much, sir. I know this was a lot for you on a Sunday evening to coordinate for us. It was so very meaningful and valuable. Sirisha, thank you for making time on a Sunday evening to come and support this. And we are truly appreciative of everyone. But before we let the audience go, I would like to, for those who are interested in the course and you want to reach out to our sales team, please give them the code Turnkey 2021. That is Turnkey 2021, and you will avail a 20% discount when you give them the course, when you give them the code, and your email address will be matched when you make a call with that particular code. So I wish you all the best, and we hope to be supportive of your aspirations and participate in your journey, as I said at the outset. And we're looking forward to an engagement in whatever way we can help. And regardless, we wish you all the very best in your careers. And thank you very much for your time. And this is from Turnkey. Thank you.
Thank you.
Thank you all.